Hey, how's it going everyone? This is Aman Dubey and I'll be discussing the Lead Code Daily Challenge problem for today, which is our absolute minimum difference in binary search tree. So, if we look at a binary search tree, the very first property that comes in mind is that all the values to the left of the binary trees, or the like all the values of the left side of the left child of the root node will be the values which are lesser than the root value, and on the right child the values will be greater than the root value. So if we take a look at this example, this binary search tree given to us, the root node here is 4, and the left child is 6 and the right child is 2. So if you see, the left child is again lesser than 4 and the right child is strictly greater than 4. The left child will always be strictly less than the parent node, and the right child will always be strictly greater than the parent node. So the another very amazing property of binary search tree is that if you do a in order traversal on this binary search tree, the elements will always be sorted in a ascending order. That's like something quite notable. So if you try to do the in order traversal for this node, like this tree, it's going to be left, root, and right. So eventually the in order traversal for this binary tree will be 1, 2, 3, 4, 6. So it's going to be left. Let me just bring MS Paint here for better understanding. I'll just draw this tree here really quick. All right. Sorry, I'm a little sick at the moment. Okay. So if we try to do the in order traversal, it's going to be the left node, root, and then the right node. So when we come on the left node, starts with 1, the root node 2, the right node 3, then again the root for this tree is going to be 4, and then the right part for this tree, entire tree, 6. Same goes with any other. Like if we take this example as well, we'll see the in order traversal is going to be all the values in the node, all the values in the trees in ascending order. 49 here. So we'll start with the in order traversal. We'll start with the leftmost. We'll start with the leftmost part. So left side, left child, 0, root for that, 1. We come on the right side. Then again for this one also, the left child first, 12. Then comes the root node, 48. Then the right child, 49. So always the in order traversal for a binary search tree will always arrange, like you'll always find the list which has all the node values, and all those, and that list will basically be sorted. So now what our questions basically ask us is to find the minimum absolute difference between any two nodes in the tree. Now since this order is sorted, then we can definitely confirm that the minimum difference will always be between any two consecutive values. Any two consecutive values will always provide us the minimum difference. We can guarantee that. Why? Because the numbers are sorted. Now it's guaranteed, like we can definitely say that the difference between 1 and 2, and that will always be less than the difference between 1 3 or 1 4 or 1 6. Why I'm saying so? Because the values are sorted. To always get the minimum possible difference between any two nodes in this binary search tree would always be in between the any two nearest adjacent values, because there are two reasons for that. First is the binary search tree, the in order to also provide us with the sorted values, and once the values are sorted, the minimum difference will always be between any two consecutive numbers. For example, here the difference between 1 and 12 will definitely be lesser than the difference between 1 and the immediate next number. It could be 13. It's going to be again like the minimum difference, whatever the difference here, plus 1. So always be greater than that. Same holds for any other pair. So we can say that to find the minimum difference values, we can just find the difference value between any two consecutive values. You just find the difference between these consecutive values and find whatever the minimum is. So in our case here, it's going to be 1, then this will be again 1, this will be 1, This will be 2. So the minimum difference value is 1. That's why answer is 1 here. Same goes for this one also here. The minimum difference value is 1. Here comes 11. This is 16, right? No, 36. My bad. 36, and here comes 1. So again, the minimum difference value here is again 1, as you see. So that's what the algorithm is. We just need to do a in order traversal on the tree, get the list of values, run a loop through them. So we can basically find all the consecutive pairs, we can just run a loop from 0 to n minus 1 or r minus whatever the length is minus 1, because for each r we're going to take the plus 1 of that. Since we don't want to go out of bound, we'll reach till n minus 2, and then we'll add plus 1, then we'll go to n minus 1. So this is basically n minus 2, 0 to n minus 2. That will be here will be n minus 1. So that's why we'll be running a loop from 0 to n minus 1. It will eventually go till n minus 2. Then we'll add that plus 1. So that's what the algorithm is. Now let's see the code. So first thing what we need to do is run the in order traversal. I'll just write a helper function to get the in order traversal sorted. Now for the in order traversal, again, it's a very standard procedure. If it's a null node, it's return. You don't have to return anything else. We'll first need to we go to the left side of the tree plus whatever value we have at the root. I need to go to the right side of the tree, and this is basically what recursion does. Now we just need to call this function, and we'll capture the list that is going to return as list1, and we pass in the root. So here the list1 is basically nothing but the values we are getting here: 1 2 3 4 6 0 1 2 12 40 48 49, all the values sorted in ascending order. Now comes the loop part. The reason we are going to n minus 1 is, I think, clear to you all. It will go till n minus 2, and then we'll add plus 1. So since we want each consecutive pairs, so for 0 we'll get 1, for 1 we'll get 2, 2 for 3, 3 for 4. Similarly for n minus 2 we'll get n minus 1. Since we don't want to go out of bound, that's why we are stopping at n minus 2. Otherwise n minus 1 will go to n and will be to out of bound. That's why we are running up till n minus 1. While 1 will be, and while 2 will be. We find the difference. Now, in order to find the minimum value, minimum difference, I'll by default like create a constant here and give it the largest possible value, which is float of infinity. Now, every time we find the difference, we'll compare it with this value. Well, every time we find a difference, we'll update the min value with the minimum of whatever we're getting with the difference of these two values. So basically, we are trying to compare if this min value here, the new min value, would be minimum of val 2 minus val 1, which is just found, and the original min value, which is float infinity. So let's say immediately we found the least value here, 2. It's going to update it as 2. If further down the line we even find a smaller value, it's going to update with that. So that's how this part works. And in the end, we just need to return this min value. Sorry for the typo. And that's pretty much it. This is the code, and the time complexity would again be O of h. We are traversing from top to bottom, height of the tree, and the space complexity will be On, number of nodes in the tree. And that's pretty much it. We hit submit. It's going to run fine. So there you have it, guys. Thank you so much.